Okay, chapter 5 is going to get into more the actions of drugs. In chapter 4, it talked about your actual nervous system and your neurons and kind of how those things work and why, drugs obviously are a huge part of that, or how our system takes in those drugs, because again, they're related to neurotransmitters that we already have. This is going to be more about what are the actual different categories of drugs, how do we test drugs, um, just some different terminology in there. Again, some of the actual physical ways that drugs interact in our body or work through our nervous system. So when you start in the chapter, obviously a good place to look is on page 101. There's just a little chart that shows you kind of the different categories of drugs, like stimulants and what falls under a stimulant. Cocaine, amphetamine, caffeine, then you have like hallucinogens. So if you work your way around there, one of the ones I would just want to point out is alcohol. A lot of times people forget that alcohol is a depressant because a lot of people will say, oh, well, when I drink alcohol, I get more active or I talk more or this or that. And so they feel like it's a stimulant when really it's not. It's a depressant. It's slowing things down in your body, hence why like your reaction time is slowed and things like that, and why uh, you're not supposed to drive under the influence and things like that is because it's actually slowing those things down. So just keep that in mind. After that, it gets a little bit more into some terminology in regards to how do we kind of study drug effects. They mention what's called a placebo. They also mention what's called a double-blind procedure. So this is talking about when you go in to research a certain drug. A lot of times what happens is uh, that you guys will see there's a whole process, and it'll start with trials, usually with animals or something like that, and then it'll work its way into the human stages where we're trying it on humans. But basically, the placebo is going to be giving the patient something that doesn't actually have the drug in it. So if we're talking about a drug study, let's say, and you're studying a diet pill, and you give certain participants the actual diet pill, and then you're probably going to give the other participants just like a sugar pill. You want it to look the same. You want it to be the same. You want them to still be taking something, because if you just had one group take the pill and then you have the other group not take the pill, sometimes just taking the pill is enough of a psychological effect for those people to claim that they that they feel a difference, and maybe they really do feel a difference, but it might be more psychological than the actual drug being administered. So if both people are taking the pills, and then in a single blind, which is you always want to try to do, they don't know if they're taking the actual drug or if they're taking the sugar pill. So whatever their responses are should be pretty honest and pretty accurate because they have no idea which one they're taking. So if they say that they're really feeling better, or if they say that they're, having some sort of effect from the drug, it's more likely that that really is the case. When you do a double blind, it's even better. Double blind means myself as the doctor or researcher, I don't even know if either who has the actual drug. And that's good for the purposes of the study because a lot of people, if they want the results to turn out a certain way, are going to be biased and try to create a certain result. So if I know this person is taking the pill that has the actual drug and they say something, I might interpret it a certain way to help my study or to help me prove the point that I want to prove. So if I don't know who's taking it, then I can't affect the study. It should be more accurate results. So those are a couple of important things to remember. Again, you're going to talk a little bit about animal testing in regards to this because, as we know, a lot of these drugs, any drugs we do tests on, whether they're over counter, whether they're actual drugs that are considered illegal, whatever it is, a lot of them go through tests with animals, and we do that for the purpose of well, we say not harming humans. But it's a huge debate, and you guys are going to talk a little bit about that and throw out some ideas in regards to that. One of the things that they talk about is how the drug can affect you, and some of the different terminology they use. They use ataxia. Ataxia means uncoordinated walking. Comatose, obviously, hopefully you've heard someone's in a coma. They are unconscious and unable to wake up. So it kind of shows you, like on page 104, it shows you with alcohol what doses put people into those different levels. So that's kind of interesting. Some other terminology: potency, how strong is the drug? Basically, what, how much do you have to take to get some type of an effect? Uh, Time course, how long is it going to last? How long is that effect going to last? How fast does it happen? Does it happen immediately after you take the drug, or does it take a while? Obviously, you guys have heard probably of different terminology of side effects. What are some side effects of the drug? If the drug is supposed to make you lose weight, but maybe there's a side effect of you have diarrhea, or fatigue, or it could be a number of things. So a lot of times you'll see, obviously, in all those commercials about drugs, people will, they'll say possible side effects, and it lists all these different things, because you have to tell people what any possible side effects that are, because people have to be aware. And if you hide anything, or if you know any of that information and something happens to that person, that's when you see all the big lawsuits and things like that. Let's see. It talks a little bit about routes of administration. This is obviously important, because depending on how the person is ingesting the drug can affect what type of effect it has on the person. So, that's one of the reasons we talk a lot about heroin being so deadly, although you guys are going to see that's not always necessarily the case. Heroin actually by itself is not as common of an overdose as what we think. A lot of times it's because it's in conjunction with some other drug. But regardless, a lot of times we talk about that because people are shooting it straight into their veins, which is a more serious type of, route of administration, because it's going straight into the bloodstream. So we'll look at different things like, how does taking something orally versus inhaling something versus straight into your bloodstream, those different routes of administration, and kind of how some of those things are absorbed in our body. Do they absorb into your fat? Do they absorb into water? There is a chart on page 110 that kind of talks about some of those different routes of administration and what are some of the advantages versus what are some of the disadvantages. So just to give you an example, you're talking about oral, someone taking something orally, the advantages would be considered it's usually a little bit safer. It's a little bit more convenient. But then when you look at the disadvantages, it's going to say your absorption rate is unpredictable. Like, you don't know how fast it's going to kick in. A slow onset a lot of times of the drug effects. So there's a whole chart about that. Make sure you know, in regards to the injection part, that some of you got intravenous, which is going straight into the vein. You've also got subcutaneous, which is under the skin, and then you've got intramuscular, which is into a muscle. So those are going to differ between each other as well. Okay. So it also starts talking about this is kind of what we talked about in the nervous system chapter, how the different drugs can have an effect on your neurons and your neurotransmitters and things like that. So one of the things that they can do, and we talked about this a little bit, is they're going to affect what is being released into your synapse, which is that open space in between your neurons. Um, it might affect how much is available of that chemical, in that space. It might affect the receptor itself and somehow keep that receptor from taking in the drug um, or the neurotransmitter, things like that. So it can affect. Basically what ends up happening is somehow it has an effect on how our system is processing the neurotransmitters that we already have, how much is available, how is it being taken back into the neuron or into the next neuron, things like that. Let's see. Just make sure you know what tolerance is. It's a pretty common word, so probably most people already understand the idea of tolerance. Something that's a little bit different in this chapter is they break it down into, they have drug disposition tolerance, and then they have behavioral tolerance, and then they have pharmacodynamic tolerance. And those things are based on what causes that tolerance to go to a different level. Drug disposition means that the drug is going to be eliminated, rapid elimination. If you look at behavioral, that's going to be some type of learned adaptation. So that's when we talk about things like conditioning, classical conditioning operant, conditioning, just learned responses to drugs, which we get more into later as well. The pharmacodynamic is more about your altered nervous system, how sensitive it is to certain drugs. So, once you use a drug a certain number of times, your actual nervous system might become less sensitive to that drug, meaning you have to take more of it. And then, like I said, for the behavioral, sometimes it's learned. So, your body might learn to respond a certain way. And so then that becomes the norm. And so then you have to take more of the drug to get some type of a different feeling or reaction because your body has adjusted through the learning process. So just keep those things in mind. Withdrawal symptoms, if you don't know what that is, again, that has to do with tolerance and becoming dependence on a substance. So if you physically become dependent, your withdrawal symptoms are gonna be what experiences your body has based on not having that drug. So, if your body becomes dependent on heroin and you don't take the heroin, what physical or psychological effects are you going to see? And those are going to be your withdrawal symptoms. A lot of times, it's going to be things like sweating, nausea, sometimes the shakes, cravings. There could be all different kinds of stuff that are withdrawal symptoms. And again, we'll get more into some of those different things. But again, for this chapter, basics, just kind of make sure you understand how some of these drugs work and the idea that they can affect the availability of certain neurotransmitters or how they're being taken into a receptor in your brain, and kind of the concept of withdrawal and tolerance and dependence. And then we're going to start getting into now the actual, as we start chapter 6, you guys will start to get to see each individual drug and kind of get more in depth to some of these basic concepts applied to each drug specifically.